All right, so this is the ultimate take two. Welcome back, mathematicians. In this video, let's look at another example of a radical equation that we're being asked to solve. So in this one, we have a radical term minus another radical term is equal to a constant. And believe it or not, that constant of 2 actually causes this to be a quite challenging and lengthy problem. So what we're going to do is have to solve this. To do this, we're going to actually move one of the radical terms to the other side. I choose the square root of x plus 2 only because it's negative on the left, and by moving it to the right, it becomes positive. And so now what I get is the square root of 2x plus 3 is equal to 2 plus the square root of x plus 2. Now, unfortunately, there's no way to just square both sides and get rid of all radicals involved. Unfortunately, that can't happen at this stage, but we can square both sides and at least get rid of one. So we're going to square both sides, and that will eliminate the square root on the left because it does undo that square root. So on the left, you have 2x plus 3. And on the right, you're going to square this. Now, so let's go ahead and off to the side, make sure that we understand what that means. So unfortunately, I've seen people that will take that square and they'll square the 2, they'll square the radical, and so what they'll get is 4 plus x plus 2, and that is not at all what you should do. What we need to do is rewrite this as 2 plus the square root of x plus 2 times 2 plus the square root of x plus 2. So what we're really doing is we're rewriting it twice like that because of the squared, and that's exactly what squared means. It means something times itself. Now I'm going to go ahead and multiply all of that out. So I'm going to go ahead and do 2 times 2, which is my first, so that's 4. Then I've got my outside, which is 2 times the square root of x plus 2, so plus 2 times the square root of x plus 2. Then I've got my inside, so it's going to be actually the same. It's going to be plus 2 times the square root of x plus 2. And then finally, I'm going to go with my last, and my last is going to be the square root of x plus 2 times the square root of x plus 2. Because those are exactly the same, I'm going to rewrite it as the square root of x plus 2 squared. So what you notice is that, first of all, I've got two like terms in the middle, and I've got the square root and the squared that can cancel each other out. They do undo each other. So let's rewrite this, and we get 4 plus 4 times the square root of x plus 2 plus x plus 2. Okay, well, we've got another set of like terms. We've got 2 and 4, which we can combine. So we're going to rewrite this as 6 plus 4 times the square root of x plus 2 plus x. And so that's as far as we can take it. And what we need to do now is then rewrite this over into our equation. So now what we have is 2x plus 3 equals 6 plus 4 times the square root of x plus 2 plus x. All right, so now what we want to do is isolate that radical on the right. And we're going to do that by subtracting 6 to both sides. And we're going to subtract x to both sides. So now what we get is x minus 3 is equal to 4 times the square root of x plus 2. So next what we'd like to do, now I've seen some people that would like to move the 4 over to the left side, and you can do that, but if you do it, you will then deal with fractions. And so there's a way to somewhat avoid those fractions early on, and that's by keeping the 4 there. So you want to move over any terms that you're adding and subtracting to the radical to the left side, but the 4 is a coefficient, we can keep it there. So let's go ahead and square both sides. Now on the left, we need to rewrite this again using what we know about what squared means as x minus 3 times x minus 3. And on the right, this is actually you're going to square both of the parts to this term. So in other words, this becomes 4 squared, and then this becomes the square root of x plus 2 squared. Okay, now this is different than before because before you were adding two terms. In this case, you're actually multiplying 4 times the square root. So that's the difference between what we were doing earlier and what we just did now. So on the left, what we end up getting is x squared minus 6x plus 9. On the right, we're going to square the 4, which is 16, and then we're going to write the square root and the square do cancel each other out. They undo each other. But here's what I have to do. I have to write a set of parentheses because what the square root also represented was a grouping symbol. So I'm going to group the x plus 2 together, maintain that grouping symbol, but the square root is gone. What I've got now is a quadratic equation. I need to solve that quadratic equation. And again, in order to solve a quadratic equation, we need to get it equal to 0. So the first thing I need to do is distribute the 16. So I've got x squared minus 6x plus 9 is equal to 16x plus 32. Now I'm going to move the 16x and the 32 to the left side. So I'm going to subtract 16x and subtract 32. This gives us a quadratic equation of x squared minus 22x minus 23 is equal to 0. Okay, so now you've got like I said, three choices. You can solve this by factoring, you can solve this using the quadratic equation, or you can complete the squares. I'm going to go ahead and factor this, and I'm going to continue over here to the right. I'm going to factor this as x plus 1 times x minus 23 is equal to 0. Now this produces two solutions. It's going to be x is equal to negative 1 and also positive 23. Now, because it is a radical equation and there's a potential that one of these or both of these could be extraneous solutions, I need to go ahead and substitute these back into the original equation. I know it feels like this is a marathon and you should be done, but we're actually not. So what we need to do now is go ahead and substitute negative 1 and also 23 back into the original equation for x to check and verify that these are actual solutions and not extraneous. So let's go ahead and do it for negative 1 first. So it's going to be the square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 2 is equal to 2. So if you simplify the two radicals, you're going to get the square root of 1 minus the square root of 1 is equal to 2, which means you have 0 is equal to 2. Okay, this doesn't work, which means that negative 1 is an extraneous solution. Let's go ahead and do the same for 23. So we go ahead and check by substituting 23 into the original equation. It's going to be square root of 2 times 23 plus 3 minus the square root of 23 plus 2 is equal to 2. Okay, 2 times 23 is going to be 46. 46 plus 3 is 49, so that'll be the square root of 49 minus, and 23 plus 2 is the square root of 25 is equal to 2. Square root of 49 is 7 minus the square root of 25, which is really just 5, is equal to 2, and 7 minus 5 is equal to 2. So this one does in fact check out. So the only solution that you have for this equation is 23. All right, you just completed a really long problem. Good luck.